Hello everyone, welcome to Mohansh Technologies. Today we are going to be discussing about the quantum computing. The first session, what is this quantum computing and how this word came into the picture. So we already know about the classic computers, right? Our classical computers. So in our regular days, whatever the computers we are using, those computers are actually called classical computers, which are going to be working with the heart like a CPU or GPU. So, the CPU is something like a central processing unit, and GPU nothing but a graphical processor unit. Okay, so let's go with the simple paint now. Let me go with the paint. I will explain how the differences, what are the major differences between the CPU and GPU and QPU. Okay, so now the thing we are working on QPUs only. That will start. We know about the CPU, right? We know about the CPU already. We know about the CPU, and we already know about the GPUs, graphic processor units. And now the concept is an emerging technology is something like QPU, quantum processing unit. Okay. So here I want to tell you a few things, guys. Okay, what CPU can contain with, how CPUs can work in a computer. In every computer or laptop, CPUs and GPUs. Nowadays, CPUs and GPUs are there, and even QPUs are also coming and emerging. Already QPUs developed with a few qubits. Okay, let me tell you about the process, how the CPUs are going to be working. So you know that CPUs are going to be working with the bits. CPUs are going to be working with the bits, like zeros, either 0 or 1, zeros and ones. Okay, CPU is going to be working with the bits. You know that. And even GPU is also working with the bits. The working mechanism of the CPU is binary format. Even GPU is also binary format. So this format is actually called binary format. Either zeros, either ones. Either zeros, either ones. Before coming all these things, for example, why computer actually needed? Why computer needed? Why your CPU related computer needed, and why your GPU related computer needed? Any computer needed for to do a task. Yes or no? Suppose, for example, if you want to write a Java program, if you want to write a Python program, if you want to write a data analytical program, if you want to write a data science program, or if you want to write something like a artificial intelligence program, whatever it may be. So nowadays, already we know CPUs and GPUs. Okay, no problem. CPU, GPU both are there. Okay, so there is a problem. There is a program you are trying to writing a program. For example, I just want to predict some weather. There is a problem, something like predicting weather. Predict weather. There is a problem, something like predict weather. Okay, there are multiple weather reports. Out there. So based on the data, I just want to. Okay, so based on the data, let me write down the things here. If you want to predict the weather, that is your question. That is your problem. So whenever you have the problem, immediately what you can do is collect the data and provide to the system. Collect the historical data. Collect the historical data based on the parameters, and you can proceed and provide to the CPU or GPU, right? So this is the traditional way. I am writing the traditional way here. You are collecting a lot of weather report data, previous weather report data, and historical information, and then you are giving to the CPUs and GPUs. Okay, so this is going to be giving you output. Something like a report is it may be little bit, okay, accuracy it may positive, it may negative, but nearby mostly 95% positive report is going to be coming. Mostly 95% positive report is going to be coming. How these positive reports are going to be coming? Why? Because of the historical data. You have the historical data. In behind, you will be applying some data science algorithms, machine learning algorithms, data analytical algorithms, whatever it may be, based on the calculations, based on the mathematics only. Based on the mathematics only, you are getting the proper output. So that output is something like you may get the output like 90% or 95% accuracy, 90 to 95% accuracy. You are going to be getting that. Okay, this is okay. Predicting the weather is okay. And these CPUs and GPUs are working already with the binary process and binary formats. Binary formats, these CPUs and GPUs are working. Okay. And this binary, suppose if I say 0, okay, 0 have some state. Okay, if I say 1, 1 also having some state. If I say 0, that is 0 only. If I say 1, that is 1 only. It is clear, very clear. Okay, something like there is a coin, sir. There is a coin. So a coin have two sides. Coin have two sides. Either head, either tail. Either head, either tail. Okay, so you say, for example, this is a coin. May coin is one side coin is head, one side coin is tail. One side coin is head, one side coin is tail. Or I can say a few other things. Okay, so head means yes, tail means no. Head means 1, head means 1, tail means 0. Okay, so state is actually state is clearly available. It is actually showing the state, it is head. It is actually showing the state, it is S. And again, it is showing the state, it is 1. And here also, tail. State is tail, or state is no, or state is 0. Okay, or it may be positive or negative. Suppose this is positive or negative. Positive or negative. Okay, so some state is clearly defining. Okay, so either live or dead. Either live or dead. Okay, available, not available. See here, the word is actually why I'm telling this one is state. It may be yes or no, it may be 1 or 0, it may be positive or negative, it may be live or dead, it may be available, not available. Very clearly, state is available. Very clearly, state is available in the two forms. In the two forms, a state is available. I am talking about classical computers. I am talking about classical computers. So all these are classical computers. I am talking about all the classical computer procedures now. All the classical computer procedures now. But coming to the QPU is quantum processing units. And this is something like emerging technology. This is something like emerging technology, quantum processing unit. What this quantum processing unit is available with? This quantum processing unit is available either 0. Okay, let me write down. It may be 0, either 0 or either 1, or it can be 0 and 1. How to write down? Let me take one thing I will do. I will take a brush here. Let me take a brush here. Then I can able to spell. Mouse. So it may be 0. So the computing process goes with zeros, or computing process goes with 1, or the computing process goes with the combination of 0 and 1. Combination of 0 and 1. So this is the position. Okay. Okay. I'm trying to write in the 0-1 combination here. The process goes with 0, or the process goes with 1. The computing process goes with 0, or the computing process goes with 1, or the computing process goes with imaginary state. This is called imaginary state. And this particular state is called superposition. This particular state is called superposition. This particular state is called superposition. Now, quantum computers are working with the superposition power. So, this superposition power is actually this one. The combination of 0 and 1 is called qubit. That is called qubit. Okay. So, here I can say this is the binary format. 0 and 1 are binary formats. But here the combination of 0 and 1 is called qubit format. Okay. So these qubits are available. These qubits are generated with quantum physics. Quantum physics. You know some quantum physics like electrons, photons, right? So these qubits are going to be generating with quantum physics, a concept of electrons, photons. Electrons, photons. Okay. Yeah, electrons, photons. Okay. Yeah, I'm just writing it. These qubits got generated like quantum physics, generating with quantum physics, and these concept, how this qubit is going to be working in the processor or in the processing units, that is going with electrons and photons. Am I clear? So, sir, already CPUs are there, GPUs are there. The next generation QPU is what QPU can do. What QPU can do. Okay, just I will tell you a few examples. Okay, I will save this architecture. I will save this diagram. Okay, so come to desktop. So on top of the desktop, I'm saving this. Okay, screen nation 1. Okay, I'll take one more picture for this. In this picture, I will explain. There is a scenario, sir. Okay, there is a simple scenario. Okay, I will write down one simple scenario. Pick up the card. Pick up card. Okay, pick up card. So when you want to pick up card, okay, you know cards, right? You know cards, right? So in the cards, I want to pick up the queen. I want to pick up the queen card. So whenever you want to pick up the queen card, what CPUs can do is, this is the task actually. It's a simple task. Pick up the card from the cards. Playing cards I'm talking about. So whenever you take playing cards, from the playing cards, I want to pick up the queen card. Then for this task, what CPU or GPU can do is, okay. You know something, CPUs are working with the sequential process and GPUs are working with the parallel process. Okay, that later we will discuss about the differences between the CPU and GPU also. But how this CPU or GPU can do is multiple attempts. They can try, for example, here I am going to be providing 100 cards. If I am providing 100 cards, first time probability, if card is come, okay, not come, try one more time, multiple attempts CPUs or GPU can do. Okay, that is actually called multiple processing or multi-processing task. A task can do with the multiple attempts or multitask processes. CPU or GPU can do multiple attempts. But the same thing, quantum computing or QPU can do in single attempt. In single attempt, it will pick up the queen card. That is the power of the QPU. Okay, if I increase the number like here, I am just giving one person this number of cards, this number of times, CPU or GPU need to be attempted. But the QPU is not like that. Even you give 1 trillion code also, 1 trillion codes also, QPU with single attempt the card can pick up. That is the power of the quantum computing. That is the power of quantum computing. There is a one more example, general example I am telling here. Okay, one person is there in the forest. One person there in forest. One person there in forest. Okay, so he want to come out from the forest. He want to come out from the forest, but he is not finding the path how to go. What he will do? What he will do? Okay, come out. Come out. Okay, searching path. Okay, searching path. I'm talking about the general examples basically, guys. Okay, one human is available in the forest, so he don't know how to go out. So he is finding searching paths. There are a number of paths he is going to be trying, a number of ways he is going to be trying. But finally, sometime after 1 day, after 2 day, after 5 day, after 1 week, after some day he will come out. Okay, finding the right path, then he will come out. Multiple attempts. The concept here is the multiple attempts. Okay, the major important point I just want to tell you here is multiple attempts CPU and GPU can do, but QPU can do a single attempt. Any task you can do, any task you can do, it will do with the single attempt. It will do with the single attempt. That is the power of the QPU. Okay, so the same thing. Here, in the single attempt, in the single attempt card is going to be picking up, green card picking up. And here also the person come out with the single way, straightforward, one way, straightforward in the one way. Okay, single way he can able to find out. Okay, this is the one more simple example. This is the one more simple example. Okay, so I can go with the one more general example. This is, okay, COVID came, right? In 2020, COVID came. When COVID came, okay, finding vaccine or inventing the vaccine. So inventing vaccine or finding the vaccine, government take a lot of time. We are having already existing good technology. We are already having very good technology like CPUs and GPUs. With the historical data, they are going to be doing the trial. N number of trials they are doing. But in the part of QPUs, only one trial. With QPUs, only one trial. In one trial only, the COVID vaccine they can able to find out. In future, I'm talking about whenever this kind of dangerous diseases will come, CPU and GPU finding the COVID vaccine, they take a lot of time. They attempt a number of times. But with the with the QPU, only one trial, one shot, automatically vaccine will become. Okay, that much higher searching pattern which is available with the qubits. That much higher searching pattern which is going to be available with the qubits. Okay, nowadays this is a real example actually, generic example in future how the QPUs will work in the future in the part of the medicine, in the part of the healthcare system, finding out the vaccines, in the part of the cyber crimes, right? So cyber crimes are going to be happening very highly. Okay, so they are going to be hacking the systems very easily. Even they have the high-level passwords like very high-level passwords like hash algorithms are. Hash algorithms? High-level hash algorithms they are maintaining, even though they will actually hacking it. Why? Because of they are trying somewhere they will hacking is going on. Hacking is going on with the CPUs and GPUs. But when QPU come into the picture, no hack. Okay, no hack. And security is very high for the financial system, for the financial systems of the India or any country. Okay, hacking is going on with the CPUs and GPUs, but there is no hack with the concept of GPU. That is the one more example I'm trying to provide here. So in the financial sector, so there are multiple sectors. These GPUs are going to be involving in the future. These GPUs are going to be involving with the multiple kind of sectors. So one is the health sector. This is going to be involving, trying to getting involving. Yeah, definitely. GPU have good capability of finding the good medicine, proper medicine. Okay, so proper medicine within short time, within very short time, not short time, very short time. Okay, and finding the diseases. Finding diseases also very simple. Finding diseases also very simple in the part of healthcare. Okay, in the financial sector, in the financial sector, in the financial, okay, no hacks, no frauds, no hacks, no frauds. Okay, different kind of sectors. Okay, in the health sector, proper medicine within short period it can able to get it, and finding the diseases also very simple. So the major advantages of this GPU is the searching process is very simple. The searching process is very simple with qubits. Okay, I hope everybody got understand what is the major part of this GPU is going to be doing in the real time. So I'm just trying to giving some simple examples. What is the difference between the CPUs and GPUs? Okay, yes, I want to draw the line here. I just want to draw the line here. How the CPUs are actually failing with finding medicine, and how the CPUs are going to be failing with the cyber attacks. In the part of cybersecurity, these GPUs are going to be giving a very good advantage in the part of cybersecurity, in the part of the medicine finding, in the part of diseases finding. Not only these things. So any case you take, any domain you take, these GPUs are going to be having a very good demand in the future. Okay, so I hope everybody got understand about the major difference between the classical computers and this superpower computers like quantum computers. The classical computers working with the binary system, zeros and ones. Zeros are there, ones are there, and state is available. Some state is available. Zero is having some state, one is also having some state. But coming to the quantum computer, either zero or either one, or either go with the qubit. Either go with the qubit. Okay, so that is the process of this QPU is working process of the quantum computing. Okay, so further we will have a lot of other sessions also there for the quantum computing. And the next session I will give you the clearly differences between the CPU, GPU, and QPU. What are the major differences between the CPU, GPU, QPU? Okay, slowly we try to enter into the multiple something like basics. These are the basics of the computers. First of all, we need to understand, before understanding the quantum computer, we need to understand the basics of the CPUs and basics of the GPUs, then basics of the QPU, then finding the differences between all these things, then how quantum process unit will work. There are some special features which are going to be available for the quantum computer, something like entanglement, quantum entanglement. And one more thing is quantum research or quantum tunneling process. So these kind of techniques we will discuss later. Okay. So if anybody not subscribe the channel, please subscribe the channel, and please like the video, comment on the video, and share with your friends also. Already I shown you there are a lot of job openings which are available for the quantum computing and emerging technology. So now IBM having the bigger quantum computer. Even Google is also in the part of a research mode. But now IBM have a good quantum computer, and IBM only having the QISKit Python library for us, Python framework for us. So we have to work with the QISKit, to work with the quantum computing, quantum algorithms and all. So this I will go and I will explain about the QISKit also in further sessions. But if you don't know Python, in our Mohansh IAM trainings channel, we already have the Python series started. 30 days Python free classes I started. You attend the Python free sessions. That is better for the quantum computing sessions. Okay. So if you search in the LinkedIn, let me open LinkedIn. I go for the jobs here. How many number of jobs which are going to be available now for the quantum computing eventually? Sir, this is not existing. This is upcoming technology, emerging technology. Now companies are hiring quantum developers, freshers they are hiring, senior they are hiring. See how many results are there? Quantum developer, quantum computing senior associate, quantum computing developer, quantum engineer. See how many number of jobs are there? QISKit software developer, IBM itself recruiting the QISKit software developer, quantum tutor. Okay, that is fine. Okay, quantum device engineer, quantum device researcher. There are a number of domains, a number of persons are going to be, a number of companies are going to be recruiting the people, sir. Okay, and one more, I will search in the Naukri also for your sake. Open the Naukri. Even Naukri also, we will be having a lot of job opportunities for the quantum computing. You can search for this quantum computing. You search for quantum computing. Yeah, I don't pick any experience. I don't pick any location. Just search for quantum computing. You can see a huge number of job openings. Oh my God, 7,520. Huge number of job openings for the quantum computing. Okay, if I keep the experience even for 0 to 5 or something, okay. Even still you will be having a lot of job opportunities which are going to be available for the quantum computing. Okay, so please like the video, subscribe the channel, and comments for the channel. If anybody want to inquire for the quantum computing, we are going to be starting a new batch very soon for the quantum computing. Okay, so you can contact Mohansh Technologies. Okay, so just log the Mohansh Technologies, search for Mohansh Technologies. You will be getting one contact form, and you can fill the form. We will notify you when the batch is going to be starting for the quantum computing. But total course will be 45 hours, dedicatedly 45 hours. Okay. Thank you. Thanks for a lot. Have a nice day. See you signing off.